Hello guys, I'm Ayswarya. Welcome to Ayswarya's Math Classroom. In the previous video, we solved questions 5 to 8 from the end of chapter exercise of chapter 1, the use of coordinates. In this video, we'll continue with questions 9 to 12. As always, I will explain each question step by step in a simple and easy way to understand. So let's get started. Question number 9. The following table shows the coordinates of points S, M, and T. In each case, state whether M is the midpoint of segment ST. Justify your answer. See here you can see S, M, and T. Here the coordinates are given, right? We have to find out if M is the midpoint of ST, and then write here in this column whether it is S or no. If the coordinates that is given over here, if it comes exactly like this, then it is S, otherwise no. And we have to give the reason. And for this, we are using the midpoint formula. The line segment, it's given. So this is S, this is T, and midpoint, this part, this is M. Okay. So the first one, it is given that S is minus 3, comma 0 and T is 3, comma 0. They have given that the coordinate of M is 0, 0. But for that, we have to find out using the midpoint formula. Midpoint formula is equal to x1 plus x2 by 2, comma y1 plus y2 by 2. Using this formula, we can find the midpoint of the segment S and T. Okay, if you're talking about this formula, just I will give you an example. See, suppose this is a line segment and I'm going to name this as A and B, and here the midpoint is M. And let the coordinates of A be x1, comma y1, and the coordinates of B is x2, comma y2. Now, to find the midpoint, using the midpoint formula, we'll take C to find the coordinates of the midpoint. To get x, we have to take the x coordinate from A and the x coordinate from B. Here you can see this is x1 plus x2 then divided by 2. When you add this one, you will get the answer for the x coordinate of the midpoint. Then to find the y coordinate of the midpoint, we have to take this 2. That is y1 plus y2 divided by 2. You will get the y coordinate of the midpoint. Is that clear? So this is a midpoint formula, and using this midpoint formula, we are going to solve this question. So here the s coordinates are minus 3, comma 0. So this is x1, this is y1. For t, the coordinates are 3, comma 0. This is x2 and y2. So we can write it as minus 3 plus 3 by 2, comma 0 plus 0 by 2. And this is equal to, this is 0 by 2, comma 0 by 2, which is equal to 0, comma 0. And they have given that coordinate of m is 0, comma 0, and we are getting the answer as 0, comma 0. So here we can write, is m the midpoint of st? Yes, it's S. And the reason for your answer, by midpoint formula. See the second question, the coordinates of S, it's given as 2, comma 3, the t 4, comma 5, and the midpoint is given as 3, comma 4. Now we'll check in the line segment S and T whether this 3, comma 4 is a midpoint. Okay, and this is x1, y1, x2, y2. So using the formula, we'll write 2 plus 4 by 2, comma 3 plus 5 by 2. This is equal to 6 by 2, comma 8 by 2, which is equal to 3, comma 4. So yes, we are getting the answer correct. See, this is 3, comma 4, and they have also given the answer as the coordinates as 3, comma 4. So this is correct. So we can write it as yes. And the reason for your answer is by midpoint formula. Now let us do the third part. The third one, the S coordinate is given as 0, comma 0, the midpoint 0, comma 5, and T 0, comma minus 10. Now let us check whether the midpoint is correct or not. Okay, using the midpoint formula. And here this is x1, y1, x2, y2. And using the midpoint formula, we can write it as 0 plus 0 by 2, comma 0 plus minus 10 by 2, which is equal to 0 by 2, comma minus 10 by 2, which is equal to 0, comma minus 5. Now, if you look here, they have given the midpoint as 0, comma 5, but by using the midpoint formula, we are getting 0, comma minus 5. So, M is not the midpoint of ST. We can write it as no. Again, how? By midpoint formula. And you can write the answer what you're getting over here. Okay, now let us do the fourth part. The coordinates of S is given as minus 8, 7. Midpoint M is given as 0, minus 2. And T is given as 6, minus 3. So this is x1, y1, x2, y2. So using the midpoint formula, we can write this as minus 8 plus 6 by 2, comma 7 plus minus 3 by 2, which is equal to minus 2 by 2 minus, here this is 7 minus 3. Okay, or I will write this for you. This plus minus will become minus, and this is minus 1 comma 4 by 2. The coordinates you are getting here is minus 1 comma 2, and the coordinates they have given is a 0 comma minus 2. So you can write, is M the midpoint of ST? This is no, it is not the midpoint of ST, and the reason is by midpoint formula, and the answer is minus 1 comma 2. I hope you understood how to find the midpoint formula. And in this, see, like if a line segment is given and to find the center, we use the midpoint formula. Okay, here there is a question like, when M is the midpoint of ST, can you find any connection between the coordinates of M, S, and D? See, in the first two cases, you got the midpoint correct. So here the connection is what? It's the midpoint formula. Yes, the connection here is the midpoint formula. I hope you understood this question. Now let us move on to the next question. Question number 10. Use the connection you found to find the coordinates of B, given that M minus 7, comma 1 is the midpoint of A, 3, comma minus 4, and B, x, comma y. So here we have to find the coordinates of B. So if you draw a line segment, and this point, this is A and B, and the middle point M. The coordinates of A is given as 3, comma minus 4. The coordinates of M is minus 7, comma 1, and for B it is given as x and y. So we have to find the coordinates of x and y, right? And here the connection is the midpoint formula. So using the midpoint formula, we can find the coordinates of B. So let's first write the formula. Midpoint formula is equal to x1 plus x2 by 2, comma y1 plus y2 by 2. Okay, now here in A, this one is x1, y1, and this is x2, y2. And the midpoint is also is already given, which is minus 7 comma 1, and that is equal to 3 plus x2 is what? X by 2, and y1 is minus 4 plus y by 2. So when we know that this is x and this is y, so comparing the x from this both sides, we'll take this one, this 2, and y we will take this 2. That means we can write 3 plus x by 2 is equal to minus 7, and minus 4 plus y by 2 is equal to 1. To find x, we can write 3 plus x is equal to minus 7 into 2, then 3 plus x is equal to minus 14. X is equal to minus 14. When 3 from this side goes to the other side, it will become negative. So x is equal to minus 17. So we found the value of x, which is equal to minus 17. Next, let us find y. Minus 4 plus y is equal to 1 into 2. Y is equal to 2, and when this 4 comes to this side, it will become positive. So we can write y is equal to 6. So we found the value of y also. So b, which was given as x, and y, we can write it as a b is equal to minus 17 comma 6. So these are the coordinates of b. So using the midpoint formula, we found the coordinates of b, which is equal to minus 17 comma 6. I hope you understood this question. Now let us move on to the next question. Question number 11. Let PQ be the point of trisection of AB with P closer to A and Q closer to B. So what does this mean? So this is the line segment. Here the end points are, see, this is A, this is B, and this line segment is divided into three parts. This is P and Q. So you can see here you have three parts, 1, 2, and 3. So this is trisection. And here P is closer to A and Q is closer to B. Then using the knowledge of how to find the coordinates of midpoint of a segment, how would you find the coordinates of P and Q? So here we have to find the coordinates of P and Q using the midpoint formula. Do this for the case when the points are A, 4 comma 7 and B 16 comma minus 2. Here the coordinates are given for A and B. A is 4 comma 7 and B is 16 comma minus 2. So here for P we will take it as x1 y1 and Q as x2 y2. So using the midpoint formula, x y is equal to x1 plus x2 by 2 comma y1 plus y2 by 2. So here the main concept is that this x is equal to x1 plus x2 by 2 and this y is equal to y1 plus y2 by 2. Okay. So here if you're taking the line segment AQ, AP, both this distance are equal and here P is the midpoint. So we can write P is the midpoint of AQ. So x1 is equal to, so here taking the x of A and x of Q, we can write it as 4 plus x2 divided by 2. And this is equation number 1. So here first we are going to find the x coordinates of both P and Q. Okay, now if you take this line segment, that is P and B, here Q is the midpoint, right? So we can write Q is the midpoint of PB. So Q is the midpoint of PB. So we can write x2 is equal to, the x coordinate of P is x1 and the x coordinate of B is 16. So we can write this as x1 plus 16 by 2, and this is equation number 2. So if we take this x2 and substitute in x1, we will get the value of x1. Okay, so we can write this as, substitute x2 in equation 1. Then the equation becomes x1 is equal to 4 plus, in the place of x2 we can write x1 plus 16 by 2 and this whole divided by 2, right? Because if you look here, 4 plus x2 by 2, there is my divided by 2 here. When we are substituting x2's value, don't forget to put this whole by 2. Okay, then if you take the LCM, it will become 8 plus x1 plus 16 by 2, this whole by 2. You can even write by 2 by 1, making this a fraction. This is equal to 16 plus 8 is equal to 24 plus x1 by 2, and taking this 2 by 1 to this side, it will become, we will take the reciprocal, right? When you change this division, it will become multiplication and it will take the reciprocal of 2, so it will become 1 by 2. So we can write x1 is equal to 24 plus x1 by 4. Then taking this 4 to this side, this will become 4x1 is equal to 24 plus x1. Taking this x1 to the left hand side, it will become 4x1 minus x1, which is equal to 24. 4x1 minus x1 will become 3x1. This is equal to 24. Therefore, x1 is equal to 24 divided by 3 and x1 is equal to 8. So the value of x1 is equal to 8. Now put this x1 is equal to 8 in equation number 2. When you put the x1 in equation number 2, we will get the value of x2. So we can write this as, put x1 in equation 2. Then we'll get x2 is equal to x1 plus 16. When you're putting the value, it will become 8 plus 16 by 2, which is equal to 24 by 2, and this is equal to 12. So we have x1 is equal to 8 and x2 is equal to 12. So I'm just going to write it over here. This is 8 and this is 12. Okay. Now using the same method, we are going to find for y1 and y2. So you can write for y1 and y2. So here again, if you're taking the line segment A and Q, P is the midpoint, and so we can write P is the midpoint of AQ. Then y1 is equal to the y coordinate of A, which is 7, and the y coordinate of q is y2, so we can write this as 7 plus y2 by 2, and this I'm going to put it as equation number 3. Now this line segment, that is pb, q is the midpoint, so we can write q is the midpoint of PB. Then y2 is equal to y1 plus minus 2 the whole divided by 2, which is equal to y1 minus 2 by 2, and this is equation number 4. Like the same method which we did previously for x1 and x2, here I'm going to substitute this y2 in equation number 3, so that we'll get the value of x1. So you can write substitute y2 in equation 3. Then y1 is equal to 7 plus y minus 2 by 2, this whole divided by 2. y1 is equal to, taking the LCM, this will become 14 plus y minus 2 the whole divided by 2, then this whole divided by 2 by 1. Then we can write y1 is equal to 12. 14 minus 2 is 12 plus y by 2, then taking the reciprocal, this will become 1 by 2, and this is equal to 12 plus y by 4. I'm going to take this 4 to the left hand side, so this will become 4. y1 is equal to 12 plus y, sorry, y1. Okay, you have to write y1, just forgot to write in between y1, and taking this one y1 to the other side, it will become 4y1 minus y1 is equal to 12, and this is 3y1 is equal to 12. y1 is equal to 12 by 3, which is equal to 4. Now substitute this y1 is equal to 4 in equation number 4, so that you can find the value of y2. Okay, so we got y1 is equal to 4. So put y1 is equal to 4 in equation 4. Equation 4 is y2 is equal to y1 minus 2 by 2, and when you're putting the value of y1, it will become 4 minus 2 by 2. Then you can write that as 2 by 2, which is equal to 1. So y2 you are getting the value as 1. So here we can write y1 we got the value as 4 and y2 as 1. Okay, question number 12, and it has got two parts. The first part is that given the points A 1 minus 8, B minus 4 7, and C minus 7 comma minus 4, show that they lie on a circle K whose center is the origin 0 0. What is the radius of circle K? So this is the question. See here in this circle, we have to prove that these points A, B, C lie on the circle. Okay, and the rate and the center, which is origin, is given as 0 0, and we have to find the radius of the circle. Means radius means from the origin to the each points. Okay, so we have already done questions using the distance formula. The distance formula is equal to root x2 minus x1 the whole square plus y2 minus y1 the whole square. But for this question, we don't need to use this distance formula. We can use instead the distance from the origin, which is equal to x square plus y square. This formula also we are getting from the distance formula only. So when you're substituting 0 in this distance formula, we'll get a smaller formula, which is root x square plus y square. So we need to use only this formula in this question. So first we are going to do find the distance from the origin to A, that is OA. First we'll find OA. OA is equal to root, using this formula, x, here x is 1 square plus y is minus 8 square. Okay, see this is x over here and this is y. So 1 square plus minus 8 the whole square. This is equal to root 1 plus minus 8 into minus 8, which is equal to 64. So this will become 64, and the answer is root 65 units. Next, we'll find the distance from 0 to B. So we can write it as OB is equal to root, here x is what? Minus 4 the whole square plus 7 the whole square, which is equal to root 16 plus 49. And this is equal to root 65 units. Next, we will find the distance from O to C, that is root minus 7 the whole square plus minus 4 the whole square. This is equal to 49 plus 16, which is equal to root 65 units. Here you can see that OA is equal to root 65, OB is equal to root 65, and OC is also equal to root 65. Means, see, if a point is on the circle, all the points will be same, because from the center to each point the distance will be always same, right? So here we are getting from OA is equal to, we are getting root 65, OB is also root 65, OC is also root 65. So all the distance here is same. So we can write, since OA is equal to OB is equal to OC, this is equal to root 65 units. Therefore, points A, B and C lie on a circle. So they have asked us to show that they lie on a circle whose center is origin O00. What is the radius of the circle K? So here the radius is also root 65, because radius means what? From this center to this point. This is the radius, right? So here radius means, see, so here we got this is root 65, this is root 65, and this is also root 65. So we can write, and the radius of the circle is equal to root 65 units. I hope you understood the first part of this question. Now let us do the second part. Second part of the 12th question. Given the points D minus 5, 6 and E 0, 9, check whether D and E lie within the circle, on the circle or outside the circle. So we have to find whether the point D and E lies inside the circle or on the circle or outside the circle. So this is what we have to find. From the first part of this question, we found out that the radius of the circle is root 65. So we can write from the first part of this question that radius of the circle is equal to root 65 units. And using the formula, that is the distance from the origin, we can find whether the point D and E lies inside or within or outside the circle. So using the formula, distance from the origin is equal to root x square plus y square. So using this formula, we'll find, first we'll find OD. OD is equal to root, see here we have the coordinates minus 5 and 6. Okay, so we can write it as minus 5 the whole square plus 6 the whole square, which is equal to root 25 plus 36, which is equal to root 61 units. Now if you look here in this circle, you can see that the radius of the circle from this point, from the center to this point is root 65, but it is inside the circle. So this will be root 61 and this point is D. So we got OD is equal to root 61 units, and which means D is inside the circle. Since root 61 is less than root 65, therefore point D lies within the circle. Okay. Now for point E, we will find using this formula, that is OE is equal to root. Here the coordinates are, you can see, that is 0, comma 9. Using that coordinate, we can write 0 the whole square plus 9 the whole square, which is equal to root 0 plus 81, and that is equal to root 81 units. Root 81 means it is equal to 9, but since all the answers are in root, we'll take root 81 itself. And now if you look, this root 81, see, root 81 is greater than root 65, right? So how this figure will be? From this point, it will be outside the circle. Here it will, because this radius from the center um, till the circle, it is root 65. So here it is 81, which means that it is outside the circle. Therefore, point E is outside the circle. I hope you understood this. It was very easy, right? To find whether these 2 points were inside the circle, on the circle, or outside the circle. So, using the distance from the origin, this formula, which is equal to x square plus y square, we could easily find out the answer. So, if you like my video, please do like, share, and subscribe. Thank you for watching.